Scientific notation is really just a simple way to handle big numbers. Scientists who study chemistry, physics, and biology often work with very large numbers, and these numbers become cumbersome and difficult to work with. So scientific notation was invented to make these large numbers much more manageable when working with complex equations. Here's how it works. Let's start with the relatively small number of 5,000. How do we write the number 5,000 in scientific notation? First of all, going from left to right, we select the first whole number other than 0. In this case, that number would be 5. We then write down that number and include a decimal point on the right side. Our next step is to add the notation times 10. Now here is where the process gets a little complex, but if you understand this part of it, the rest is fairly easy. We need a number right here. The number is a superscript to the 10. In mathematics, it's called an exponent. But how do we determine what the exponent will be? First of all, ask yourself this question. How do I convert 5 into 5,000? Well, I add 3 zeros. Zeros are really just decimal place holders, so in essence, I've added 3 decimal places to the right of the 5. If that sounds confusing, try this. Draw a line on the right side of the digit that you are using to begin your scientific notation. In this case, it would be the number 5. And then count the decimal places to the right. 1, 2, 3. And that's our answer. The exponent will be the number 3. Notice that 10 to the third power is 10 cubed, which is 10 times 10 times 10. And that equals 1,000. And 5 times 1,000 equals 5,000. So what you see on the screen are 2 different ways of writing the number 5,000. But what if we have a number like this, 5,123? There are no zeros in this number. Does that make a difference? Well, there is a slight difference, but nothing significant. We start out the same way we did before, by looking left to right and writing down the first whole number that is not a zero. And once again, that will be the number 5. Now this time we have other numbers that are not 0, and we have to write them down also. Then just like last time, we write down the notation times 10, and all we have left to do then is to determine the exponent number for 10. And we do that the same way we did before. Remember, we're trying to convert the number 5.123 into the number 5,123. So we draw our line and we count the decimal places. There are 3 decimal places, so 3 will be the exponent number for 10. What you see on the screen is the same number written 2 different ways. The top number is written in the standard format that we are all used to seeing, and the bottom number is written in scientific notation. In this example, the scientific notation is even more difficult to write down than the standard format. So why even do this? To answer that question, let's go back to the mole and the number that it represents. Now let's write 1 mole in scientific notation. Looking from left to right, 6 is our first whole number other than 0, so we write it down. Then we add the decimal and write down 022. The 0 in this case fills a decimal place between 2 whole counting numbers, so it is important to include it in the first part of our scientific notation. Now we add the notation times 10, and to determine the exponent of 10, we draw our line and count the decimal places to the right. and there are 23 decimal places. So our exponent will be 23. Here we can clearly see why scientific notation is a simpler way of working with large numbers. Now we know how to write scientific notation for whole numbers. In video 2 of this series, we will learn how to write scientific notation for fractions.